Welcome, everyone, and thank you for joining us today. My name is Kara, and I'm with the LTAP Center here at ODOT, and I'll be your host for this webinar. Today's webinar is the fourth session in our Pedestrians and Bicycles Meeting the Needs four-part series, and we're excited to have Ron Eck as our presenter. Before we begin, I'd like to cover a few housekeeping items to ensure a smooth webinar experience for everyone. If you have questions during the presentation, please use the questions panel on your screen. You can type your questions there and we'll address them as appropriate throughout the webinar. If you're experiencing any technical difficulties or have any other issues, feel free to use the chat panel to communicate with our team and we'll do our best to assist you. A PDF of today's presentation is available for your reference in the handout section. Please note that this webinar is being recorded and the recording will be made available to all registered attendees after the session. All right, with that out of the way, let's get started. It's my pleasure to hand it over to Ron Eck. Ron, the virtual floor is yours.
Thanks, Kara. Good morning, everyone. Welcome back to Bicycles and Pedestrians. This is day 4, our final day of the 4-part class. Let me just review. Here's our agenda for today. You may recall last time we were talking towards the end of class about bicycle facilities, including shared facilities and wide curb lanes. We're going to continue that today and talk about several other types of bicycle facility types and the considerations involved with each. We'll look briefly at bikes and on-street parking, also briefly at wayfinding systems for bicyclists, and also bicycle parking and end-of-trip facilities. Then we'll look at shared use paths, which we've talked about throughout the session, but we'll look at them in more detail, and we'll wrap up with a rails with trails example. At some point yesterday, I did mention use of green-colored pavement for bicycle facilities. So I wanted to start out by talking about that. Green-colored pavement is used to enhance the conspicuity of locations where bicyclists are expected to operate and areas where bicyclists and other traffic might have potentially conflicting, weaving, or crossing movements. You see an example there in the photo. That's downtown Charlotte, North Carolina. The driveway, which you can't see on beyond that on the left, but it's a large church with a school, so it's busy, very busy 5 days or 7 days a week, I should say. And so they have installed, I'll get my cursor here. You can see at the driveway where the potential conflict would be between bicycles and motor vehicle traffic, they've installed a section of green pavement. The green colored pavement can also be used to enhance the conspicuity of word, symbol, arrow markings when those markings are used in certain bike facilities. And I think you can see here too, notice how the symbols in white and the arrows and such stand out pretty well on that green background. Green colored pavement is addressed in the MUTCD, and its use is not a requirement, but notice if it's used, green colored pavement shall be limited to bike lanes, extensions of bike lanes through intersections, as you see in the right-hand photo there, extensions of bike lanes through areas where motor vehicles enter a mandatory turn lane in which motor vehicles must weave across bicycles in bike lanes, 2-stage bike turn boxes, which we'll talk about, bicycle boxes we'll also talk about, and then also as a background for the bicycle detector symbol.
Ron, we have a quick question for you.
Sure.
Someone asked, is the green color per the MUTCD, are they able to use a different color?
I assume that means for bicycle facilities, and the response is no. Green is kind of the color the manual reserves for bicycle facilities. I believe red in the new manual is reserved for bus facilities, separated bus lanes, but bicycle facilities, green is the color. Good question.
Thank you. One more question. Let's see here. So they're clarifying. They want to make sure that they do not want to have a whole bike lane green along the roadway.
You could, but it's not required. Many agencies do, for example, what you see on the lower left image here, which I believe I cut from the MUTCD, but notice they've just made green the portion where bikes will kind of be stopping at the intersection, at the stop line, like motor vehicles, probably to let the motor vehicle operators here in the right lane that might be turning right here, let them know that this is the bicycle facility, kind of a reminder. So hopefully they'll be less likely, for example, sort of cheat and move toward the curb there. But that's correct. The entire bike facility does not need to be green. Just areas where you want to kind of highlight maybe potential conflicts or crossing or weaving areas.
Wonderful. Thank you so much for answering that question, Ron.
You're welcome. The manual also gives some directives, because notice the word shall there, of where green colored pavement shall not be used. Shall not be incorporated into electric vehicle parking stations or parking stalls, not incorporated into crosswalks, although as you see here, they can be adjacent to the crosswalk, but not in the crosswalk. Not to be used as background for shared lane markings. You may recall we talked about those on Tuesday, the sharrows. You cannot use green as a background for those shared lane markings, and shall not be used instead of the required markings for bicycle facilities. The green color may be retroreflective, but that's not required. It does not have, the green pavement does not have to be retroreflective. And the use of the green colored pavement should be consistently applied consistently throughout the bike network and can be used to improve the legibility of the bikeway network. If green colored pavement is not used throughout a network, it's recommended that it be used to guide bicyclists through transition areas between different bikeway types and bikeway crossings to improve legibility of the route. I mentioned bike boxes. These are designated areas on the approach to a signalized intersection consisting of an advance stop line and the bicycle symbols, as you see in the photograph below. They're mainly used to mitigate conflicts between through bicyclists and right turning motorists, and to reduce conflicts between motorists and bicyclists at the beginning of the green signal phase. Kind of gives the bikes, they're out front, they're more visible, and they can get a head start. The MUTCD provides bike box guidance. Usually they should not be installed across more than one travel lane. Their use is limited to signalized intersections. They should not be used at other locations. And at least one bike symbol shall be placed in the box to indicate that it is for bicycle use. Should be a minimum of 10 feet in depth, maybe larger depending on anticipated bike volumes. If you have more bike volumes, it might be deeper than 10 feet. And it should be connected directly to the approaching bike lane. The manual says at least 50 feet of bike lane should be provided on the approach. And notice it's the approaching bike lane and the bike box may be colored green. So they don't have to be green, but they might be. And so if you allow me to back up here I mentioned this bike box, notice the symbol. It's hard to tell, but it looks like it's 10 feet deep approximately, as we mentioned. And notice the green lane here, kind of as we talked about regarding the question earlier. Again, I haven't measured that, but it looks like it's probably about 50 feet on the approach to the bicycle box that we have the green pavement. And I think I also mentioned the two-stage bicycle turn box. This designates an area at an intersection that's intended to provide the bicyclist a place to wait for traffic to clear before they proceed in a different direction. And these can be used for right turns or left turns, and may be used at any signalized intersection, but preferably on high volume, multi-lane roads to reduce the need for bicyclists weaving across motor vehicle traffic. So here's an example of a two-stage bicycle left turn box. You can see, so the bicyclists traverse the intersection within the bike lane. Here's the bike lane coming through. So this would be the bike lane. And then they stop within the turn box here and reorient themselves to cross the street. So these bicyclists will be making a left turn here. So they don't have to leave the bike lane to weave across traffic. They stop here, reorient themselves, and then wait for the signal for the cross street to be able to proceed. This is what the manual says about two-stage bike turn boxes. They must be located outside of the path of through and turning traffic. They should be located adjacent to the direct path of bike travel, as I just showed you in the previous slide. Should be downstream of the crosswalk and downstream of the stop line. If you allow me to back up here, notice not very far downstream, but it is just that. Here's the crosswalk. And so the two-stage bike box is just downstream of the crosswalk. Must include a bike symbol along with an arrow showing the direction of turn. So in the two-stage bike box, that symbol must be included. Recall it's optional in the bicycle box. And also it must be bound by a solid white line and may be supplemented with green colored pavement that encompasses all of the two-stage turn box. So the green pavement, again, is not mandatory, but notice this one, they did use green pavement, and the box is outlined with a solid white line around the perimeter of the box. Also, a no turn on red sign needs to be installed where a two-stage turn queuing box is not located outside the path of right turning traffic to prevent motorists from entering that bicycle queuing area. And passive detection of bikes in the two-stage bicycle turn box must be provided if detection is required to actuate a traffic signal. And here's an example. This is from the MUTCD of the signing associated with a two-stage bicycle turn box. So notice you can see the box here. Next to the bike lane, but downstream of the crosswalk and stop bar. And then you see, since that, given the location of the turn box here, notice there is, here I should say, here. Notice there is a no turn on red sign. And then upstream on the approach here is a sign, regulatory sign indicating for bicycles, left turn from the bike lane to advise them they don't need to weave across traffic. They can make the left turn from the bike lane. And then up here, this is a little bit harder to read, but this, again, a regulatory sign with the bike symbol. So this applies to bicycles. And it says left turn from, or I'm sorry, it says left turn must use turn box. Left turn must use turn box. So they're advising bicyclists, they're turning left, they need to use the bicycle box. So I wanted to talk about those a little bit before we get into the next type of bike facility, which is the bicycle lanes. And this is a portion of the roadway designated for preferential use by bicyclists. And we use pavement markings to designate that lane. And here you see a couple examples. Bike lanes should be a hard, smooth, rideable surface, clear of defects, like we talked about on Tuesday, no debris accumulation. The surface conditions should be free of joints and seams and cracks and holes and things, and any other potential obstruction. Minimum width should be 5 feet, but if the lane is adjacent to the curb, 6 feet, because of the fact that the bicycles will shy away from the curb. They need to be signed and marked according to the MUTCD. That is a white lane line and bike symbol markings or word markings. The markings may be supplemented with the directional arrow marking indicating the correct direction of travel in the lane. And this is from the MUTCD. This is a sketch or drawing showing the bike lane at an intersection. Notice the dashed lines here where right turning vehicular traffic may cross the bike lane to enter the right turn lane, while the bike lane alignment essentially proceeds in a linear fashion. What about bike lanes adjacent to parallel parking? We had a question about this, I think, last week. And the issue here is what's called dooring, where the door opens and may strike the bicyclist, or the open door may be struck by the bicyclist. Both of those are potentially serious situations in terms of causing harm or injury or loss of control to the bicyclist. And as you see here, it's estimated that dooring incidents typically account for about 2 to 10% of urban bike crashes. And they most commonly occur when bikes are operating in shared lanes. The door zone typically extends about up to 10.5 feet from the curb. Considerations to address this include diagonal pavement markings into the bike lane, wider bike lanes, a buffered door zone, and I think we mentioned Tuesday on shared facilities, location of the sharrow or the shared lane marking can also be an approach to use. So that was parallel parking, but of course, on some roadways, we may have diagonal parking of vehicles. And this is an issue if it's head in or front in type diagonal parking, since of course motorists backing out of the spaces have very poor visibility of bicyclists in the bike lane. And so it's better to convert to back in diagonal parking to improve the sight lines between parking motorists or unparking motorists and approaching bicyclists. So I think I have larger versions of these photos. So this shows from the bicyclist perspective, their view of parked vehicles on the roadway ahead. And notice if the back-in angle parking is used, notice the bicyclist can virtually look the driver in the eye here and has a clear indication that the motorist is ready to pull out. But it also provides a good indication or good sight lines for drivers that they can see oncoming bicyclists clearly and hopefully yield for them until they've passed. And back-in parking does seem to become more common, at least my perception over the recent years in observing diagonal on-street parking. Another type of bike facility, which is experimental, so I want to emphasize that, but you do see it mentioned often in different web discussions and that sort of thing, are the advisory bicycle lanes, or they're also called edge lane roadways. But in the MUTCD, or in more recent discussion, or I should say, I guess the AASHTO Bike Guide, they refer to them as advisory bicycle lanes. It's basically a continuously dotted bike lane which permits motorists to temporarily enter the bike lane so that opposing motor vehicle traffic has sufficient space to pass. So notice you see here on the left, relatively narrow roadway, not really, or travel way in terms of striping for traffic, not really wide enough to accommodate two vehicles in the opposite direction. And then we have the shoulder for bicycle use. But then notice when an oncoming vehicle approaches, the vehicles are allowed to use part of the shoulder to pass each other. And of course, they would need to yield for the bicyclist using the shoulder. And you'll notice here the shoulder is colored differently from the traveled way. That's, I think, beneficial, but I don't believe that's required with the advisory bicycle lanes. So I think I've talked about most of these points. Yeah, the pavement color is optional, but the pavement markings, of course, are critical. And where advisory bicycle lanes are installed, they should include bicycle lane signs and bicycle lane symbol pavement markings. And again, I want to emphasize that anyone's interested in using this, you do need experimental approval from Federal Highway Administration. They're still collecting data and analyzing the data, operational safety and other data, I think, before it would get approval to appear in the MUTCD. And here's an example from, this is Hanover, the town of Hanover, New Hampshire. They have advisory bike lanes you can see through a residential area. And notice there's no parking this side of the street sign, which would be important as well. And I think you can see from the image, the traveled way is not wide enough to accommodate two motor vehicles side by side, but the vehicles could use the shoulder in the event of passing an oncoming vehicle. And further note, in this case, the shoulder is just the normal asphalt bituminous surface of the roadway. They did not color the shoulder in this case. Another type of bicycle facility is the bicycle boulevards. Bicycle boulevards. These are local streets that accommodate motor vehicles, but they're basically designed to prioritize bicycle travel. Typically used on streets through residential areas that have low volumes of vehicular traffic. But if you look at this kind of rendering here or conceptual sketch, I think this shows kind of some of the key features of a bicycle boulevard. Notice there's bicycles and motor vehicles, but also notice there's, in this case, there's speed humps to slow traffic. On the left side here, there's a kind of a residential area, traffic circle to bend the traffic stream to keep speeds low. On the right side here, notice there is a median island on the cross street such that motor vehicle access is prevented. So motor vehicles basically have to turn right here. But notice there's cut-throughs in the island to allow passage of bikes. So just as I said, we're allowing motor vehicles on this street, but in this particular example, it's not really a through street. But for bicyclists, it is a through street. And I think we've talked about most of these things. So it does combine road markings, traffic calming measures, crossing improvements to give priority to bicyclists and to enhance their comfort, to keep vehicle speeds low, traffic volumes low as well. And it is considered a low stress shared roadway concept. And here's an example from San Luis Obispo, California. You can see it's in a residential neighborhood, and it's hard to tell, but I think in the distance, I think those are speed humps, although they're not marked. but you could put speed humps or other traffic calming measures on the street. And then notice vehicular traffic coming toward us is forced to turn right, but bicyclists have the gaps, openings in the median island, so they can continue straight ahead, whereas the vehicular traffic must turn right. Another bicycle facility is the separated bike lanes and side paths. And here's an example of a side path, Lake Tahoe, California. Notice it's a shared use facility. Both bikes and pedestrians can use this. And it's separated some 5 feet or so, maybe more, from the roadway, and essentially follows the roadway alignment. It's typically bidirectional, and it's been found to offer good experience for users of all ages and ability. And as I mentioned, typically kind of the minimum separation from the roadway is 5 feet. And then the pathway would follow the shared use path design guidelines. One of the issues, though, with the side paths is what happens at intersections, which may be with roadways or with driveways, because notice of course, the path is almost immediately adjacent to the roadway. And so how do you handle turning movements? And this concept rendering shows how that might be done. Notice they've kind of moved the path away from the roadway a little bit, which may be a function of right-of-way availability. And then they're using a speed table or raised crosswalk for the actual crossing, with the idea of trying to slow vehicular traffic that's turning into this driveway or side road, whatever it might be. And then notice this driveway or side road has a median island here, and of course a stop line back here or yield line. And then, of course, for accessibility considerations, since the crosswalk or the path is crossing a roadway, we need to have the detectable warning surfaces on both sides of the facility there. So those are the side paths.
Ron, we have another quick question.
Sure.
Excuse me. Someone would like to know if the path, let's see here, if the side path intersection configuration puts bicyclists and pedestrians into conflict.
I mean, yes, it does, but probably the same as a shared use path would.
Mhm.
They're sharing the same facility. So yeah, there are those potential conflicts, and we'll talk a little bit about those conflicts within the next, well, maybe next 40 minutes or so. We'll talk about that. But yes, there are potential conflicts between users.
Okay. And I have another question.
Sure.
Are snow plows given special instructions on and around bike lanes and bike boulevards?
Oh, great question. Bike lanes, yeah, they would need to be, have special procedures or special instructions. Bike boulevards, I would say probably so, but it might be the same sort of instructions that you would have for traffic calming measures, which, I live on a street with speed humps on it here in Morgantown, and I'm not sure what sort of special training they did for our city crews above and beyond their normal dry runs. But when the snowplow operators make their dry runs in the fall, that's a good time to advise them or talk about what needs to be done in terms of plowing the hump. But really, at least on my street and here in my city of Morgantown, the plow operators I think they don't have to do anything special other than maybe raise the plow a little bit or other things like that. But There might be issues with roundabouts, for example, some special instructions for plowing, or I should say the residential area traffic circles. And there may be a need for some additional work. This may be manual type activity to keep the, if the streets are plowed, there might be windrows of snow. And so you might need, I don't know, maybe a skid steer or just manual labor to keep these openings in the median barrier clear. So yes, it would involve some extra instruction or extra activity, I guess. Good question.
Wonderful. I actually have a couple more.
Okay.
Um, we have a question asking, is there a maximum ADT for bike boulevards and advisory bike lanes?
Oh, great questions. And I'm not sure I have seen any. I'm not sure I've seen any, although I would add, pardon me for backing up again, but my personal opinion is that the advisory bike lanes are really, and this is Ron's personal opinion, are really, most suited for what I would call low traffic volume roads. And some of you may know I actually serve on the low volume roads committee of the Transportation Research Board. So I'm kind of familiar with this topic. And I've seen low volume roads with volumes anywhere from as high as 2,000 vehicles per day down to like 400 vehicles per day is a cutoff. But generally, I would say, yeah, you want these to be low volume, traffic volume roads. The same thing for the bike boulevards. You don't want high speed or high volume through traffic. Those work best on the more minor streets where you can give priority to bikes and don't have to worry too much about through vehicular traffic.
Okay, wonderful. And we have some more questions.
Okay.
To verify, they're wanting to know truncated domes and detectable warnings would still be required for shared use path when it intersects with an uncurbed roadway, as in like rural locations.
That is
Correct?
correct. That is correct. I'm not sure I have an example of that coming up when we talk about shared use paths, but yes, that is correct. Anytime a pedestrian facility crosses a motor vehicle facility, a roadway, let's say a roadway, where there is no curb, there needs to be detectable warning surfaces.
Wonderful. Three more questions.
Okay.
If you're building a bike lane or shared use path, does eminent domain powers work if you need private property?
That's a great question, and that is probably going to vary state by state, because I believe states have different laws in that regard. So I'll have to defer and say maybe check with your agency attorney or legal counsel about that. So I don't really want to I don't feel comfortable giving a kind of a global answer for that, since I think that will be kind of location specific.
Okay, that makes
Good
sense.
question
Thank
though.
you. Yeah. Is there anything provided for skid resistance within the green bike boxes or green painted area?
Yeah, and I don't know if these show it. I apologize for going back so much here, but these are good questions. This looks, and it's hard to tell. I took this in Washington, D.C. last year, about a year ago. I think this is just paint, but some of the manufacturers do produce a material. I'm not sure if it's an epoxy or what it is. I shouldn't say what it is, but it has some skid resistance built into it that is, it's much more, significantly more skid resistant than just paint on the surface. So there are materials available, yes, to do that. And I would think that, you do want to pay attention to to the skid resistance. Another technique might be to put some grit or like a silica material in the paint, much like you might find in say, like certain like auto dealerships, their service departments may have a gritty type of paint because of the presence of fluids and things like that on the floor surface.
That sounds wonderful. And one last question so we can keep this webinar moving along. Someone was wondering if you know if ODOT supports the use of advisory bicycle lanes.
Great question, and I have to admit, since I'm not in Ohio, I don't know the answer to that question. I don't know if there's anybody online that maybe with ODOT that can answer that and chime in the chat.
I will keep an eye out for that answer and share if someone does give us an answer to that. And other than that, we are done with questions, so you may proceed.
Okay, thanks. And great questions. I appreciate the good questions. So let's see, I mentioned separated bike lanes. Over the years, I guess they've been called cycle tracks or protected bike lanes, but I think currently the most common usage is separated bike lanes, which are an exclusive facility for bikes located within or directly adjacent to the roadway, but physically separated from vehicular traffic with a vertical element. And we'll look at what those vertical elements might be. So the cross section has three distinct zones. The separated bike lane, that's the space where the bicyclists operate, right here. The street buffer that separates the bike lane from vehicular traffic, and here we have a couple. We have these flexible delineator posts, which is the vertical element in this case, but it also looks like there's a parking lane here. So this street buffer kind of has two elements, the traffic control, but also parking. And then we have the sidewalk buffer that separates the bike lane from the sidewalk. And in this case, it looks like it's a buffer strip or furniture zone or tree lawn, many, many names given for that area, but that would be the sidewalk buffer. Separated bike lanes, I think, are regarded very highly by users. They're considered to be part of a low stress bike network because of the separation. And here you can see an older user as well as some younger users who are out enjoying the facility, low stress facility. And also you can see both of these use the vertical flexible delineator posts as the buffer.
We do have a little bit of a answer to the question. I received a message from one of our ODOT LPAs who said that they have used advisory lane on a local let project and that they haven't had any issues so far.
Okay, great. Thanks for that additional information. And again, nationally, that you would need to get the experimental approval from Federal Highway Administration. There has been guidance over the years on separated bike lanes. Probably the first kind of quote official guidance came in 2015 when Federal Highway Administration published its separated bike lane guide, and that covers some of the planning considerations, gives a menu of design options. Then in 2019, FHWA issued its bikeway selection guide that provided some more guidance. And the late 2004, the new edition of the AASHTO Bicycle Guide presents some detailed guidance on design, operation, and maintenance of separated bike lanes. So there is some good information resources out there for planners and designers and maintainers. The surface needs to be smooth, stable, slip resistant. I'd probably avoid the use of pavers. They're not generally considered a smooth surface. The bike lane should be free of obstructions if possible, things like grates and utility covers. those kinds of things. The design of the separation should be based on, you can see here, a number of different things, including whether on-street parking is present, the overall street and buffer width, obviously cost is a factor, durability, aesthetics, traffic speeds, emergency vehicle and service access, and also maintenance, which would include snow removal. Here are some of the vertical elements that have been used, planters or concrete traffic barriers, lower raised medians, bollards, wheel stops or parking stops, the flexible delineator posts. I showed you some examples. And here's another example of using those flexible delineator posts as well as the vehicle parking. That would be considered a vertical element too. Obviously not always there, maybe, but can be part of that buffer. Some more examples here you can see using, on the left is a two-way facility. It looks like in this case they did pretty much make the entire facility the green pavement. And then they have the flexible delineator post separating the vehicular traveled way from the bike facility. And then on the right, I think that's Denver, Colorado, but notice they're using, it's a one-way facility with planters. Bike lane width depends on a number of factors, including street characteristics, the demand, maintenance again, type of curb, and also the elevation of the bike lane, which we'll talk about. Minimum widths range from like 5.5 feet for one-way operation to 9 feet for two-way operation, and that's exclusive of the street buffer. And remember that because bikes shy away from hazards, the proximity to streetscape furniture, different vertical elements we've talked about, or vertical curbs may reduce the usable width. So the physical width may be wider than the actual functional width because of the vertical elements. And here you see some information on the separated bike lane widths for one-way versus two-way facilities. And another issue may be curb types for separated bike lanes, to separate them, for example, from the sidewalk or the pedestrian facility. And this is from the new AASHTO bike guide. They present 3 different curb types. You can see a mountable curb, kind of a gently sloped curb, then a more steeply sloped curb, and then a vertical curb. Sloping curbs are probably preferred to reduce pedal strikes and to make it easier for the bicyclist to access the sidewalk. They can also be detected by the vision impaired who are using a cane, where you have the bike facility and the sidewalk at the same elevation side by side. There needs to be some ability for the visually impaired to detect or distinguish the bike facility from the sidewalk. Mountable curbs are designed to be traversed by bicyclists. The forgiving angle reduces pedal strikes, and again, they may be reliably detected by the blind where there is an elevation difference of at least 2 inches. If vertical curb is desired, use a short curb reveal, say 2 to 3 inches, to reduce pedal strikes. And again, to be detected by the vision impaired, these short curbs should be no less than 2 inches high. Curbs that include a gutter should generally be avoided in separated bike lanes, and the gutter is not included as part of the bike lane width. I mentioned separated bike lane elevation. The bike lanes actually can be designed at any elevation from flush with the street to flush with the sidewalk and anything in between. Here's a list of some of the factors that should be considered in making the selection of bike lane elevation. Notice that includes drainage, intersection frequency, maintenance again. Accessibility should be part of that. as well as curbside conflicts. So here's sidewalk level separated bike lanes. Notice here's the street over here on the right with the curb, and then the street buffer, and then the bike lane is at sidewalk level, and then the sidewalk is here. And so there needs to be some sort of sidewalk buffer, or as I said, some way so that the visually impaired know when they're moving from the sidewalk to the bike lane to keep them on the sidewalk. And here are some examples. This is from Seattle, Washington. This is a sidewalk level separated bike lane. Notice the bike lane here, clearly marked. Notice the use of the green. This is a driveway from I'm not sure what sort of building this was, I don't remember, but it's a potential conflict as vehicles pull in and out of that driveway. And so the city put in the green pavement here to highlight that potential conflict point. And so here's the sidewalk. They're at the same elevation. And so they use this type of, what's that? I guess a plastic or composite material with the delineators on it to separate the bike facility from the sidewalk. And I guess from an ADA standpoint, it would be great if these were continuous, but they are very closely spaced. So I mean, I think that would be detectable by someone with the cane. That brings us to something I think I mentioned last week, and that is the so-called directional indicators. I should back up, and in the United States, or not in the United States, everywhere, there are two types of what they call tactile warning surface indicators, TWSI, tactile warning surface indicators. And one I think everybody's familiar with. One type of TWSI is the truncated dome detectable warning surfaces that we just talked about a few minutes ago that are used at the bottom of curb ramps or when a path crosses a street and there's no curb. The second type, so those detectable warning surfaces, ADA, as you're probably aware, has specifications for them in terms of the dome height and the spacing and the arrangement. They are kind of a standard indicator in the United States. A second type of tactile warning surface indicator is what's called the directional indicator. And it's to provide information to the visually impaired to help them kind of navigate along a sidewalk and say not go into a bike facility. Or they can also be used to direct the visually impaired toward a mid-block crosswalk, for example. But the thing I want to emphasize with directional indicators is that right now in the United States, there's research underway. In fact, there's quite a bit of research underway. But right now, there's no standard design or no regulatory requirement for the use of directional indicators. And one type of directional indicator is shown here. I tried to put a penny in the photo, but it's hard to see the penny. But I wanted to give you an idea of this would be one panel that could be attached to the pavement and could, for example, go many tens of feet or hundreds of feet to say separate a bike facility from a sidewalk. So you can see it's kind of a low linear surface, raised surface. You know, it has to be detectable by a cane tip for the blind, but also it can't be a tripping hazard for able-bodied pedestrians. And also, for example, if this is a bike facility here and this is the sidewalk and a bicyclist runs across this, it can't be a surface that would cause the bicycle to go out of control. So there's a lot of different users and their needs and abilities that have to be taken into account. But there are a number of cities around the country, maybe some of you who are with us in this class are using this. So I think we're collecting some good data and information on safety and operational aspects of these directional indicators. Here's one. This is the city of Philadelphia waterfront. You can see this is the sidewalk. And then next to it this is the bike facility. And notice in the background, for much of the facility, there was like a 2 or 3 foot wide strip of landscaping. And that's, of course, detectable by a pedestrian using the cane. So that's a good separation. But notice here, for some reason, they had to put the bike facility next to or immediately adjacent to the sidewalk, and they're flush in terms of elevation. So there needs to be something to kind of distinguish that for the visually impaired. And you can see they use the directional indicators here. This is a little bit different design than the one I showed you. As I said, there's no standard yet, but there are some designs that are available from different manufacturers. There's also one kind of a trapezoidal design that's getting favorable reviews as well. This is Seattle again. Here's an example of a directional indicator on a sidewalk bike lane at a corner. And you can see there's a lot going on here. Notice Seattle also uses the artistic crosswalks. We mentioned that the other day, but this is the bike lane here. It's sort of hard to see. You don't see much of the lane except at the corner here, but this is the bike lane. This is the sidewalk. And so where the sidewalk enters the street and the curb is missing, we need to have a detectable warning surface. That alerts the visually impaired that they're entering the street. But of course, we can't really use that here in the bike lane because we don't want pedestrians in the bike lane. But so the city here has put in, excuse me, the design that I showed you in the photograph with the penny. These are the directional indicators. So if a blind pedestrian gets into this area, they can detect that and will go to either their left or their right and hopefully find the pedestrian crossing in this environment. We could also have street level separated bike lanes where the bike lane here is at the same level as the street. Notice there is a curb height here between the bike facility and the sidewalk. So that curb height is detectable by the cane that a blind pedestrian would be using. And so we don't really need to worry about the directional indicators here. The curb is the directional indicator, if you will. And then we could have intermediate level separated bike lanes where the street is here, the sidewalk is here, and the bike lane is at some elevation in between. But again, as I mentioned earlier, to minimize potential encroachment or conflicts with the visually impaired pedestrians, I would suggest a minimum 2-inch vertical separation. I think I mentioned many of these things, the sidewalk buffer zone. And here's a separated bike lane at an intersection. This is Seattle again. This is the sidewalk. This is the bike facility, separated bike facility. It's at sidewalk level, but here on this block, you can see they're using, what's that, maybe a 3-4 foot wide buffer strip that's filled with landscaping and vegetation, mulch, and that is detectable under the cane tip. So the visually impaired should not get into the bike facility. But notice here, you can see the crossing, the bike facility. This is the sidewalk. This would be the detectable warnings here and under this individual's feet. And then these are also detectable warnings for where the sidewalk crosses the bicycle facility. Or actually, I guess these might be the directional indicators because I guess this is the crossing here, where the sidewalk crosses the bike facility. Maybe use raised crossings or curb extensions to limit turning speeds. Here you can see a conceptual example using the raised crosswalks to reduce turning speeds. Protected intersections. This preserves the separated bike lane up to and through the intersection, and they eliminate shared spaces with turning and merging vehicles. They limit bike exposure to a single point where the motorist turns across the bike lane and the adjacent pedestrian crossing. And the geometric design, the curb radius, is used to control speeds. There's a corner island that protects bicyclists by controlling the speed. The bikes kind of queue up forward of the vehicular traffic so that they're in the line of sight of motor vehicle drivers, and the bikes can enter the intersection before the turning vehicles. There's also mountable truck aprons that slow turning vehicles while still allowing the large vehicles to proceed. There's recessed crossing to create motor vehicle yielding space and allows drivers to see pedestrians without relying on their mirrors. The pedestrian crossing islands reduce crossing distances, and you need to have at least 6 feet between the bike lane and the travel lane, and that needs to include detectable warning surfaces. And then there's delineator islands that separate pedestrian and bike crossing. So here's a schematic. Notice we have the separated bike lane here and here. Notice the vehicular traffic stops back here, and the bicycles there would be here and here, so that they're clearly visible, for example, to right turning traffic. And in fact, these bicyclists then get into the roadway before the vehicular traffic arrives. And this, notice this is the sidewalk, or the pedestrian path crossing the bike lane and crossing, and this is the island that was referred to. This needs to be a minimum of 6 feet in the direction of pedestrian travel, and we need to have detectable warning surfaces on both sides of the island, and here as well. Another design is the intersection with mixing zones. So this requires turning motor vehicles to merge into the separated bike lane at a defined location in advance of the intersection. And this is compatible only with one-way separated bike lanes. Probably protected intersections are preferable to these mixing zones. Mixing zones generally appropriate as kind of an interim or retrofit solution, or where right-of-way constraints make it not feasible to provide a protected intersection. Some considerations: should be limited to constrained locations where maintaining physical separation is infeasible, with a maximum of 50 to 150 turning motor vehicles in the peak hour. Consider signal separation at constrained locations with higher turning volumes. And the bike lane should be continuous through the mixing zone if space permits. Otherwise, shared lane markings should be used. Consider a green bike lane or shared lane markings for the conflict area to highlight the conflict point and to raise awareness of bicyclists. Provide a buffer with vertical elements to separate the turn lane from the through lane, and the design should reduce motor vehicle speeds to 20 miles per hour or less. The length of the mixing zone should be minimized to 60 to 100 feet to maximize comfort for bicyclists and to minimize speed differential with motor vehicle traffic. And may need to restrict parking to increase approach site distances. And here's a schematic of the mixing zone. Notice the separated bike lane here, and then we are shifting the path of the bikes to this location, and this is the right turn lane where motorists need to cross the path of the cyclist to get into the turn lane. And this is the taper we talked about. So you can see there's a lot going on there. Need to give good information to both bicyclists and motor vehicle operators. Transit stops, we talked about transit a little bit yesterday, I think, or Tuesday. Guidance is to route the separated bike lane behind the transit stop to eliminate bicyclist conflicts with buses and pedestrians waiting at the stop. Although I think I'll show you an example here of one where that's not the case. You do need to guide passengers across the bike lane at clearly marked locations. 2 ped crossings are recommended, but not required. Channelizing railings or planters or other treatments can be used to direct pedestrians to the crossing locations. This is Seattle. You can see the bike lane is here. The bus stop is here. There's a shelter. Notice that this shelter creates a potential sightline obstruction, so they put in a section of railing here to at least get the pedestrians who are headed for the sidewalk. You know, hopefully the lines of sight are improved by moving them away from the transit shelter. Here's one in Kansas City. You can see the bike lane here on the left, and then it ramps up to sidewalk level here, and then is next to the sidewalk. So notice they've used the directional indicators here so that the visually impaired will know where the sidewalk is and not venture into the bike lane. This is Washington, D.C. In this case, notice that here's the potential conflict between the bike lane and transit users who may be waiting to or boarding the transit vehicle. Just some general guidance on separated bike lanes. I think they should be deployed strategically. Use a context-sensitive approach. You can vary the separation type or alignment depending on the specific conditions, and think about how a separated bike lane network or system could help build a low-stress bicycle network, and as well as provide connections for disadvantaged populations. I think we mentioned on Tuesday, winter maintenance may require special equipment for separated bike lanes, since if there is that buffer, which I guess there is under the snow here, you know, a conventional snowplow can't get into that separated bike lane. So you may need special skid steer or small tractors or those types of devices to clear the separate bike lane. Wanted to mention briefly wayfinding systems for bicyclists. Some of the core principles would be simplicity. You know, it should be easy to use and kind of intuitive wayfinding to help bicyclists navigate and understand where they are in relation to landmarks or destinations. Consistency. There should be sort of a common style, fonts, colors, materials, placement throughout the community to help promote continuity and help users kind of quickly understand and interpret messages without having to stop their bicycles. The MUTCD does address this issue. Also, AASHTO's new bicycle guide, they talk about destination-based wayfinding, and the MUTCD talks about this. This is from Charlotte, North Carolina. This photo, notice they identify that this is the bike route, the user is on the bike route, but then they identify some specific destinations in that immediate area. And they also talk about route-based wayfinding, which could be national routes, there's state routes, but maybe also local, state, or nationally significant shared use paths. And guidance on this, as I said, is given both in the MUTCD and in the new bicycle guide. Wanted to say a few words about bike parking and end of trip facilities. I think bike parking should be provided at all publicly accessible buildings, parks, other destinations, and also included, you know, in roadway, streetscape, and transit projects. Really, wherever car parking is required, there should also be some bicycle parking. Types of bike parking, there's really 3. There's short-term parking, intended, you know, for shorter stays where people may be, you know, going into a shop or a recreational facility or a business, not to work, but to conduct business, like pay a bill or pick up something, those kind of things. That would be short-term parking. Longer-term parking would be what, say, residents in a multi-unit building might need, or employees who arrive maybe before 8 and leave before 5 p.m. They need long-term parking during their workday. Similarly for maybe transit users. So here we're talking about several hours to a day to maybe even multiple days. And then the other category, maybe not quite as common, is temporary event parking. There may be large organized bike rides or concerts, sporting events, festivals where people arrive by bike, and it's a good idea to provide temporary event parking. And many large cities actually have requirements for temporary event bicycle parking. Some of the basic bike parking principles should be quality equipment or devices. The bike racks should meet some performance criteria, should be located next to or close to destinations, building entrances, bike routes. Designed so that the bicyclist can ride to or from the parking without having to dismount, and should try to minimize conflicts with pedestrians. Should involve also personal security, so the location, the lighting, the visibility of the bicycle parking should provide personal safety and security for the people storing or unlocking their bikes, but then also bike security, to deter theft or minimize damage to parked bicycles. Remember, I think on Tuesday of last week, we talked about some of the barriers to walking and biking, and I mentioned destination type barriers. Lack of good, secure, safe bicycle parking is a destination barrier that may discourage folks from bicycling. Could have on-street parking, what are called the bike corrals. Here, this is Washington, D.C. Notice I guess this was an on-street parking space that now is allocated through the use of pavement markings and these vertical elements. This is now a bicycle corral for on-street bicycle parking. This is from the AASHTO Bike Guide. They give examples of bike racks, both, I would say, acceptable, highlighted in green, and then the unacceptable due to the issues, various issues with the three types of racks you see at the bottom. End of trip facilities, locker rooms, showers, shower rooms, repair stations, not required, but optional, and help overcome those destination barriers that I talked about on the first day of this class. So that brings us to shared use path design, or multi-use trails, or bike paths, but these are kind of the independent facilities that are separated from the road or the street, typically. There's a variety of different types. There's rail trails, there's rails with trails, meaning trails adjacent to an active rail line. The rail trails are typically trails that occupy the same space that in the past were active rail lines, but those lines were closed and abandoned, and now they're trails. Could be greenway trails, trails in utility corridors, paths in large residential or commercial development, canal trails. I mentioned side paths, paths adjacent to roadways. Number of planning issues. These are going to probably be unique to the different trail types, whether it's a rail with trail versus a rail or trail on a converted railroad right-of-way, or whether there's a historic canal next to it versus paths adjacent to roads. We talked about the intersection issue a little while ago. Some of the common community issues are personal security, fear of crime. This may apply to both the trail user and also to the adjacent land uses, as well as traffic safety issues. If the path is next to or adjacent to a roadway, or where the path crosses a roadway. And the paths we're talking about here serve both transportation and recreation. And where they're hard surface paths, they need to comply with the PROAG requirements. One concern that comes up, an issue comes up, is what about motorized vehicles? It could be vehicles, or it could be conventional vehicles. It could be golf carts, mopeds, motorcycles, ATVs, snowmobiles on trails that are intended for non-motorized users. And that, those users, of course, may have different dimensions, certainly different speeds, different operating characteristics, and so they do create conflicts with slower moving bicyclists and pedestrians. And of course, it's those safety concerns that leads many to not allow the motorized modes on these paths. And also, I guess it could diminish the recreational experience that many users are looking for on a path, just a multi-use path for pedestrians and bikes. So how do we restrict motor vehicles? That's one of the challenges. Many agencies use bollards of various types or similar measures like Z-gates or fences that are placed within the clear width of the shared use path to restrict motor vehicle traffic. Generally, these are not recommended, although I know they're widely used, but bollards are a fixed object hazard to bicyclists, especially, also to pedestrians. And so, in fact, the AASHTO bike guide, the new guide, as some of you may be aware, actually, I guess several locations talks about bollards and the adverse consequences of bollards, but they also talk about, if you're going to use bollards, how to do it to kind of minimize some of these adverse consequences. And in fact, the bike guide says bollards, actually it should be not used. I just caught that. That should say bollards should not be used unless there is a documented history of unauthorized intrusion by motor vehicles. So again, bollards should not be used unless there's a documented history of intrusion by motor vehicles. But if they're necessary, and this comes from the bike guide, consider the use of the flexible delineators, so they're not as much as of a fixed obstacle, and they should be a minimum of 40 inches high with a minimum diameter of 4 inches. And I would add that, to me, they should also be colored brightly and also marked with retroreflective material so that they're visible, clearly visible, both day and night. And notice the AASHTO guide says placement should permit passage of adult tricycles and bikes towing trailers and should not require the user to dismount. Also, of course, it should not restrict access for people with disabilities, and install them at locations where vehicles cannot easily bypass the bollards. Where one bollard is used, it should be aligned with the center line. And make sure there's adequate sight distance to the bollards so that users can see them. So visibility obviously is critical with bollards. Here's some examples on the left. It's in the shadows here, given the time of day, but I mean, I think this is a relatively good installation. Notice the bollard is painted white for the most part, so to enhance visibility. And then it's got, what's that, maybe a foot wide strip of orange and white diagonal reflective tape wrapped around it to enhance both daytime and nighttime visibility. And then notice they use pattern is in the MUTCD. Notice how the center line goes around that bollard, and the bollard, it appears, is in the center of the trail or the path. The right image, I don't know, I wasn't involved in this project. This is in Las Vegas, Nevada. I was just there as a tourist a few years ago, and I don't know what happened here, but this is clearly not desirable, not safe. This center bollard, to me, should be at the center line, and then this one, I guess, is properly located on the right, but this one should be on the edge of the pavement here on the far left. And they do have reflective tape around them, it appears. I guess personally, I think I have an issue with the color only because that lighted brown, reddish brown seems to blend in with some of the natural stone, and rock formations in that area. It might be better to pick a color that provides better contrast to make them more conspicuous. But this to me is a concern because I think that's a tort liability claim exposure there if someone's harmed due to those bollards. Some of the trail design issues, the path surface and treadway design, how wide, what surface type are we going to use? Geometric design, the curves and grades, what sort of access and restrictions are we going to have? If the path or trail is close to the roadway, what do we need special provisions at intersections and those kinds of things? What about environmental impacts, aesthetics, amenities? Could be things like signage, benches. We see a bench here along the trail. Those, I would call these amenities. They're not required, but I think they have great benefits, but they also need to be designed and incorporated appropriately. And signage, and also any structures. There may be bridge structures that are involved. In terms of design users of shared use paths, talk about maybe 3 different types here. Adult bicyclists probably should be used to establish the curves and grades and the width of the path and design speed and so forth, and clearances, since they're probably maybe the fastest moving user and are traveling maybe the trail or the path for longer distances. The recumbent bikes, which I think we mentioned in the opening class, they should be used to establish sight distance because the operators there have the lowest eye height compared to, say, an adult bicyclist. And they may also have the fastest approach speed of all users. And then probably pedestrian and child bicyclists should be used to establish the intersection crossing performance criteria, since they are typically the slowest of the path users. This is a sketch of a typical shared use path cross section, 10-foot minimum from pavement edge to pavement edge, and then you see the different minimums, graded shoulders and clear distances and so forth. And again, 2% maximum cross slope to comply with ADA. I mentioned earlier today the idea of actual width versus functional width. This is a portion of the Truckee River Trail going into downtown Reno, Nevada. This is probably 20 years ago or so. But notice that from edge of this wall here to the top of this wall is 10 feet. So that would comply with what I just presented. But notice there is a railing here, maybe 6 inches off the edge. And if you consider that this railing will need a shy distance of maybe 1.5 to 2 feet, the actual width of this Truckee River Trail here is not 10 feet. It's maybe more like 7 feet or so, which is not sufficient for two-way travel. And when I took this photo, like I say, about 20 years ago, you can see there wasn't a whole lot of traffic on the trail. In fact, it had just opened recently. But I was in Reno a few years ago, and this trail is now heavily used. And actually, it was interesting. There's a parallel street here that now this portion of the trail you see here is one-way inbound to the city, and a part of the local street outside the view on the left here is the outbound trail. There's a number of conflicts that can occur on trails. You can just see from the image here. I guess this is a good problem to have when your trail is heavily used, but we do need to be aware of the potential conflicts that can occur. And so here are some techniques for minimizing conflicts on trails. I know there was a question about that. How do we educate folks? I think in the first class last week. But here are some potential ways of dealing with those through signage or education, maybe eventually even expanding facilities, or in some cases, segregating users. Here's some examples of signage. The one on the right, I believe, is Portland, Oregon. That's along the trail, intended to be read while people are moving. The one on the left is, I believe it's the Boise River Trail in Boise, Idaho. A lot of signage here. This is placed at the entrances or at connections to the trail because people obviously need time to kind of stop and take in that information. Clearly, those signs cannot be read at speed. Here's an example of segregating users, bikes, in this case on our left, pedestrians on the right. But again, remember, this would be a good place where maybe you need those directional indicators to provide detectability for the vision impaired. Where shared use paths intersect roadways, I would say follow the same design guidance as you would use for roadway intersection design. I'm speeding up here a little bit in the interest of time, but if you have questions, hopefully we'll have time at the end. Here you see a shared use path crossing a roadway, and you can see there's traffic control both on the trail and on the roadway. Entrance and wayside amenities, a number of different things. Again, these are amenities and options. They're not requirements, but these are things that enhance the user experience. And here's an example. This is Washington State on the left, a nice facility at kind of a trailhead, at shelter, vending machines, restrooms, maps, a green roof, very well done facility, I thought. And I think this is the same facility. Notice they provide motor vehicle parking, also bicycle parking, bicycle repair facilities. All of these amenities are, I think, appreciated by the users. So in the time we have left, I did want to briefly go over an example of a Rails with Trails project in Western Maryland. It's about maybe 70 miles east of where I am here in Morgantown, West Virginia. Generally, there's not too many Rails with Trails projects around the country because the Class 1 railroads, the larger railroads, generally do not want active trails next to their operating railroads because of potential safety and liability concerns. But this is one where I think it's been successful because the railroad is not a normal Class 1 railroad, it's an excursion railroad. And here's a map to orient you. Washington, D.C. is down here, Pittsburgh is here, and this project occurs on the trail that there is a trail, as you may be aware, that connects Pittsburgh and Washington. And this is roughly halfway or at the midpoint of that trail network. And here's a Google aerial view where we're talking about. We'll start in Cumberland, Maryland, elevation about 625 feet. The portion kind of at the end of where we'll talk about is in Frostburg, Maryland, elevation 2,000 feet. So I'm going from Cumberland to Frostburg. You can see it's a pretty good uphill grade, and then the trail continues up into Pennsylvania and on to Pittsburgh. But it's a very popular trail. Maybe some of you have used parts of it. It's been a great boon to economic development to communities large and small throughout this corridor. And this is the excursion train that operates maybe a couple times a day in the summer, much less frequently in other seasons of the year. But it itself is kind of an attraction. But then you can see, notice there's not much separation other than a few feet of railroad ballast to separate the trail from the active rail line. So here's what it looks like kind of just outside Cumberland, Maryland, just as we saw in the aerial now, just a few feet of separation between the trail and the tracks. Kind of the same thing in the more rural mountainous areas. There is a notable bridge structure. This used to be a 2-track structure. There is still the active rail line on the other side of the railing here, but notice this is the timber boardwalk for where the track used to be for the current present day path or trail. Interestingly, there is one tunnel on this alignment, and that raised some issues or concerns because you have folks on foot and on bike sharing a tunnel with a locomotive that's belching out steam and cinders and things. And so clearly you don't want people in the tunnel when the train is passing through. So the group that developed this spent a lot of time discussing how to handle this. They talked about an active sort of flashing light system with gates that would kind of, clearly advise people when the train was coming. But they ended up using this static warning system because I should mention, you probably appreciate that steam locomotive is not exactly quiet as it's approaching the tunnel. It can be heard for literally for miles. And so there's not really an issue with people being caught by surprise, but they did want to warn the users. And so this is the warning they used, with the idea that if this doesn't work out, then they'll upgrade to an active system. But thus far, I don't think there's been any issues. This is what it looks like inside the tunnel. You can see there is some lighting. There is a barrier, a cable type barrier between the trail and the tracks. And some people ask sometimes, well, wouldn't you want a more substantial barrier? And probably intuitively you would, but interestingly, this is the barrier type that was insisted on by the railroad. They indicated they need to have access to the track and the rail and the ballast for maintenance purposes, so they wanted something that could be relatively easily moved or removed. So that's the reason for that barrier type. There are some road crossings. You can see how those are done. There's some places where the trail crosses the tracks to the other side, and you can see the treatment here. Notice the detectable warning surfaces and the markings and signing. And this is at the Maryland-Pennsylvania state line. Notice the bollard installation. I don't know the history of this, but this is at the center line, which is recommended. This is at the edge line, and this may be because the motor vehicles are trying to get around the bollards on this side of the trail, so they added some additional bollards. But note, I like these bollards. They're conspicuous. They're bright yellow. They have some white retroreflective tape wrapped around them, and so to me, that's an example of a good bollard installation. And I think that covers everything. We have a couple minutes left if there's any questions, but I want to thank everybody for participating, for your great questions. Hopefully.
Ron, did we lose you? Oh, I think we just lost Ron. Well, I'm glad that he was able to make it through the entire presentation. If he is able to get his audio to work again, we do have a couple of questions to ask him. So if you would like to hang on for a moment, I do see that he's active on his screen. So, you know what?
Do you
I'm
hear
going to
me?
go ahead. Oh, I just heard you. You're back. Welcome
Oh, did
back,
I
Ron.
disappear?
You did disappear. Yes, we were missing you.
Oh,
Um,
wow.
yeah. So, but I was just telling everyone that we did lose audio with you for a moment, but we were glad you made it through the presentation, and then that we do have a couple of questions for you right now. It's 4 questions, so I feel like we have time to do that if you don't mind.
No, that's fine.
Wonderful. Okay. Well. We had a question asking, can separated bike lines be used by e-bikes? And if yes, should there be a maximum speed?
Yeah, great question. I think from my perception is that that again is kind of a local jurisdictional thing. I think I'm aware of some places that where they are permitted, but others where they're not. And certainly the speed would be a key consideration in terms of potential conflicts and things. I'm not sure what would be a commonly, kind of used or recommended maximum speed though.
Mm, that makes sense. Thank you for that answer. Next question. This person has read that bike advocates express that white flex poles represent a greater danger because of visibility issues. Can you speak to that?
I'm sorry, I didn't hear all you said. White.
Oh, so they're saying that, yeah, the white flex poles represent a greater danger because of visibility issues. And they wanted to know if you could speak to that.
Uh, in
Well,
terms
I
of
think you.
not being as visible, maybe, or
Yeah, I think that some people, some bike advocates have just expressed that they are not a big fan of the white flex poles because they have trouble seeing them. So this person was just wondering if you had anything to share about that.
yeah, I've not heard that. That's interesting. To me, the key thing in terms of visibility is contra of anything really, people in the road or bicycles or traffic control devices, is contrast between the feature like the person or the sign or the flex pole and the background. So I mean, I guess I could see some environments where the white might not be as visible, but on the other hand, I could see other environments where white might sort of pop out at you more than other colors. So to me, it would seem to be very context sensitive. In fact, could even vary along a particular bike route or bike path or bike lane. But that's
Yeah, and
interesting. I've not heard that before.
yeah, well, and it looks like this person did elaborate a little bit more. And they said that they've seen advocates say that flex poles are not a hard barrier, so they're not as safe as bollard or other objects. And when they are damaged, they also create objects in the lane, and that they also prevent plowing. So this person is asking how they might deal with those situations.
Yeah, I mean those are all valid comments, but I think any type of separator for one thing, is going to interfere with plowing.
Mm,
Although,
hmm.
well, yeah, any whether you have a low median or planters or whatever, they're going to interfere with plowing. And I mean, I recognize, yeah, when they get bent over, they're going to be a issue, an obstacle in the path. But again, I think any sort of vertical element, except maybe a low curb, but even planters, if they get struck by a motor vehicle from the outside the path, those planters could get knocked into the trail, and for some period of time until they're removed, could present an obstacle to trail users. It's just
Yes,
a matter, I guess, of the trade-offs given the particular environment where your particular path is, in terms of, is snow removal a big issue, or uh,
absolutely.
roadway departure, vulnerability, those sorts of things that would factor in.
Excellent. That definitely makes sense. Okay, well, and we have one last question. Someone says, what manual is the schematic of mixing zones taken from to know what the numbers to reference would be?
That comes from an FHWA publication, I want to say in the 2015 to 2018 timeframe. I believe it was called Multimodal Transportation, and they talk about sidewalks, but also a variety of different types of bicycle facilities, and I believe maybe also some of the NACTO urban street design publications talk about those as well.
Wonderful. Thank you for that piece of information. And also thank you again so much for that incredible presentation. So many things to think about and to notice. Um, on behalf of LTAP and ODOT, I'd like to thank you, Ron, for sharing your knowledge and expertise with us. As mentioned earlier, the recording of this webinar will be shared with all registered attendees. So I would just like to thank you all for attending, and we hope you found this webinar informative and engaging, and we hope you have a wonderful rest of your day.
Thanks again, everyone. And thanks for your help, Kara.
My pleasure, Ron.